such solutions that are not dominated by others. So let us somehow, for example, randomly change the variables and watch what happens with the result. And we will only remember solutions that are not dominated by any others we have so far found. What we will have now, after obtaining a lot of those solutions, we will have something which is called Pareto-Farad. If we have tried every possible combination of variables x1 and x2, we would get a real Pareto-Farad, which would, for example, look like this. If we are only approaching to get the Farad, I mean we are generating more and more solutions, some of them dominate others, so we will forget those that have been dominated by new solutions. We have something like an advancing Pareto-Farad that moves and finally would create the final Pareto-Farad, which really has the property that any point on the Farad is Pareto optimal. So any point in the Pareto-Farad would be Pareto optimal. That is, if we improve G1, we have to disimprove G2 or vice versa. Now this is a very simple kind of Pareto-Farad. Just imagine that we have, for example, 10 variables and the Farad could be continuous but also could make isels somewhere. But anyway, after knowing this Pareto-Farad, that is, after using a numeric method and after many iterations, finding those dominated solutions and the new solutions, we have to take care that we find the whole Farad, that the method only does not identify a piece of that, for example, but that's not important for the idea, that's the method. After we know the Pareto-Farad, we can now make trade-offs, because we know what is possible, what is achievable, but we know also at what cost. We know that if we want maximum G1, we will only get this G2. And if we want maximum G2, we will only get this G1. But we can make this trade-off with full knowledge of the situation. Well, this is quite simple. In 2D, that is, there are two goals. It gets less simple if we have, let's say, 4 goals, because we can't draw the result into one picture. We only can make slices, and based on those slices, we can make decisions. So far, there is no industry standard for a thing like that. On the other hand, a Pareto kind optimization could give you a complete picture of what possible solutions differ in. Basically, you can get a fully qualified trade-off, not at the beginning, because at the beginning it's not fully qualified, you do not know what is possible. So you can do that at the end on the cost of a lot of computer load, but knowing the Pareto-Farad may help you to decide in a qualified manner about your trade-offs, because unfortunately during circuit or antenna or technology design it's always about trade-offs. So again, important ideas. Pareto optimal is a solution in which you cannot improve in one goal without decreasing the performance in other goals. or at least in one other goal. That's the Pareto optimal solution. There mostly is a number of Pareto optimal solutions, and you can make trade-offs between those solutions. In order to get this trade-off, you should know a Pareto front. Pareto front consists of all solutions that are not dominated by other solutions. And if you want to somehow create or find out a Pareto front, the way that is known now is to create a lot of solutions and remember only those who dominate or are not dominated by any other solution that you have already in the set. Well, gentlemen, your questions to Pareto optimization. A little bit different point of view on optimization, but anyway important. Is this at least a little bit clear what Pareto meant by his ideas?
Yes.
Well, now, some business software provide you with some insight into Pareto fronts. It's still not very much seen on the market, but I think that this is one of the approaches that will be more frequent in the future. Still, the biggest problem is not the calculation and the load of the computer. The biggest problem, in fact, is how to describe a Pareto front, which is, for example, a curve in 8-dimensional space. You have to make cuts, which is not very convenient, so the computer should somehow select the cuts, but then it can oversee the correct solution. So this is still something that should be somehow worked out before it enters the market fully. But the idea of Pareto optimality is an important insight into reality needed for an engineer. This is why I try to tell it to you, despite of the fact you can't buy it, in fact. Gentlemen, are there more questions? As there are no more questions, in the next lecture I will start about yield analysis and design centering, which is not a topic for a whole lecture. So then I will switch to start with non-linearity handling. Unfortunately, most of the universe is not linear. With linear circuits, you would never get an amplifier, detector, and so on. So the most important circuits are nonlinear, and we would have to handle it at least a little bit. So that's what we will touch in the next lecture, which will start at 9:15 next week on Tuesday. Gentlemen, it's been a pleasure to teach for you. Looking forward to meet you, and have a nice week since then. Bye.
Thank you. Goodbye. Thank you. Goodbye.